Hello student, welcome to yet another lecture series on Fourier sine transformation. I already uploaded plenty of the videos on Fourier sine transformation, Fourier transformation and its inverse transformation. If interested to see this video, do check in my playlist. In my today's video, I'm gonna explain to you all Fourier sine transformation for our given function. Okay, yes, let's get dive into today's example. I'm gonna explain to you all the complete solution over here. Okay, yes, so as we want the Fourier sine transformation, so we know that the Fourier sine transformation can be defined as capital F S of S. Okay, F S of S, then we write its a formula 0 to infinity small f of x. Okay, it is a small f of x sine sx, okay, sine sx dx. Okay, this one is our required Fourier transformation formula. Okay, so that one we are going to apply here for the solving this integral. Okay, now see that as we have given integral 0x 0 strictly less x strictly less a. Okay, 0 strictly less x strictly less a when we have function f of x is a sine x, and when we have function f of x is 0, then we take all the value for x which is bigger than a. Okay, that means we have interval for this sine x. Okay, we have the interval for this sine x which is a 0 to a, but you don't need to take the interval for 0. If you are going to replace f of x 0 here, so this entire integral gives us the value 0. Okay, so we don't have to worry about this function f of x which is equal to 0 for this interval. Okay, so we are going to consider this interval only for sine x. Okay, so replace f of x as a sine x, replace its interval. Okay, now see that how I am going to replace interval 0 to a. Okay, 0 to a, it is the interval as we have interval given 0 to a. Okay, f of x is a sine x, f of x is a sine x, sine sx, okay, dx. Okay, we have here sine x sine sx dx. Okay, this one is our given Fourier transformation. And now see that we are going to solve this one. Okay, we are going to solve this one, this integral. Okay, now we integrals further. Now we can see that sine a sine b form it is there. Okay, so as it seems like that we need here factorization defactorization formulas from the trigonometry. Okay, so I'm going to explain to you all how factorization defactorization formula we have to apply. Okay, yes, capital F S of S. Okay, this one is a Fourier sine transformation. Now see that sine A sine B, there is no any formula for sine A sine B, but I know there is the formula for 2 sine A sine B. Okay, I know the formula for 2 sine A sine B. Okay, and 2 sine A sine B can be written as cos A minus B minus cos A plus B. Okay, we write cos A minus B minus cos A plus B. Okay, this one is the expansion for 2 sine A sine B, which is cos A minus B minus cos A plus B. Guys, you all need to remember these formulas. These are very much important here. Okay, yes, so if you want to see this formula, I will show you all here factorization defactorization formula. Note it down and keep it for your preparation. So guys, these are the 8 formulas. These are very much important here. About 1 2 3 4 5 6 7 8. Okay, so these are the factorization defactorization formula. When we have product of the trigonometric function, then that time we apply it here. Okay, using this formula we are going to solve our given integration. Okay, so I already show you all here for our given formulas. Okay, yes, now see that we have 2 sine A sine B, but sine A sine B it is given here now. We don't have 2 here, so what we do, we multiply 2 divide 2. Okay, so nothing matters when we multiply with the same term. Okay, and divide with the same terms. I multiplied 2 and divide 2. Take 2 outside of the integral. We left here with the value capital F suffix S, means Fourier transformation or sine transformation of S, which is equal to 1 by 2 outside here. Okay, integral 0 to a 2 sine x sine s x dx. Okay, now see that what we have formula. Okay, so how to apply the formula for 2 sin x sin sx? Okay, that means 2 sin x sin sx, we write cos s minus sx minus cos s plus sx. Value for a it is a x and value for b it is a sx. Replace these values here. Okay, I'm going to write it here. Okay, yes, 1 by 2 it is here, integration over 0 to a. Now see that guys, why I'm applying this formula. If we are going to solve this integration as a sin x into sin sx, this one comes as a by part rule, and we cannot apply directly by part rule for this function. Okay, as none of the function can vanish. Okay, that's why we are going to convert this function into the simplest form. Okay, that's I'm gonna do here. Okay, yes, so 2 sin a sin b can be written as cos a minus b means cos x minus sx. Okay, minus cos x plus sx. Okay, and outside we have dx here. Now see that I got the simplest form here. Okay, simplest form for our integration. Take x common from here, so I'm going to write 1 by 2 integration over 0 to a cos of 1 minus s x outside minus cos of 1 plus s x outside. Okay, yes, and complete the bracket and dx outside here. Okay, now see that I just taken x common from here, so that we can easily apply integral on given cos function. Okay, yes, apply integration cos of theta. Cos theta, we know that integration and differentiation of a cos. Okay, yes, and cos has a integration sign. Okay, and cos has a derivative minus sign. Okay, yes, so we are going to apply d by dx of cos x, which is a sin x. Sorry, d by dx of cos x is a minus sin x, and integration of cos x. Okay, integration of cos x, which is a sin x. Okay, so we are going to apply this one here. Cos x has the integration sin x. Okay, and cos x has a derivative minus sin x. Yes, we are going to apply this integration here. So keep 1 by 2 as it is, under bracket cos x has a integration sin 1 minus s into x. Okay, and divided by differentiation of 1 minus s into x, we write 1 minus s. Okay, differentiation of this term 1 minus s into x has differentiation 1 minus s. Okay, minus cos 1 plus s into x has a differentiation sin 1 plus s into x divided by 1 plus s. Okay, that means cos x has a differentiation sin x. Okay, and denominator differentiation of that x here, that means 1 plus s into x has a differentiation 1 plus s here. Okay, so I completed these these steps here. Okay, yes, now see that guys, similar step, and we have to apply integral over 0 to a here. 0 integral 0 to a, upper limit lower limit, don't forget it. Okay, so otherwise we do not get the final answer. Okay, now see that here we have to replace that 0 and a. We know that we applied integral under dx. So wherever you found x, replace a and 0. Okay, yes, first I'm going to replace a here. See that how carefully I'm going to replace sin 1 minus s into a. Okay, sin 1 minus s into a divided by 1 minus s minus cos 1 plus, sorry, sin it is there, sin, this one is, I'm going to take this term as it is, x replaced by only a. Okay, 1 plus s cos 1 plus s into a divided by 1 plus s. Okay, bracket complete, minus of, if x replaced by 0, entire goes 0, x replaced by 0, entire goes 0. That means next step it completely goes to 0 here. Okay, yes, so we want the answer. For Fourier transformation, yes or yes. Okay, this one we want the answer. So you don't need to solve, guys. Okay, if you want you can take 1 minus s 1 plus s. We cannot take this one common as denominator are completely different. Okay, so our required answer, Fourier transformation of s, Fourier's transformation, sine transformation, we write it as the 1 by 2 sine 1 minus s into a upon 1 minus s minus sine 1 plus s into a upon 1 plus s. Okay, this one is our required answer. I hope you all have understood this my entire solution. It's one of the easy solution, guys. Don't have anything difficult. Just need to apply simple formula for Fourier transformation. Okay, you will get the directly answer. So I hope you all have understood my today's lecture, guys. So even after, if you found anything difficult now, let me know in my comment section. I will come up with a similar video. So thank you everyone. Thank you for my today's lecture.